In today's lesson, we'll be learning how to convert standard form to factored form with a focus on decomposition. In a previous lesson, we learned that changing factored form to standard form is called expanding, and changing standard form back to factored form is called factoring. Decomposition is just a type of factoring. In today's example, we'll be changing standard form back to factored form. And we'll be doing that through factoring. More specifically, we'll be using decomposition. It is recommended to use decomposition when a is not equal to 1. What exactly does that mean? Well, a is not 1. It is positive 6. That means we'll be using decomposition here. We want to start by looking at a and c. But what exactly is A and C? Well, A is positive 6 and C is positive 1. So I'm going to copy those numbers down over here. Positive 6 and positive 1. That looks like 61, but it is not exactly 61. It's actually 6 multiplied by 1, since there's a hidden multiplication sign between them. So 6 multiplied by 1 gives me 6. Next, let's take a look at B. Well, B is actually positive 5. So I'm going to write positive 5 right over here. At this point, we want to think of two numbers that multiply to give us 6. And the same two numbers must add up to give us 5. You'll want to use guess and check here. I'm going to start by using the numbers 2 and 3. Since 2 multiplied by 3 gives me 6. So that works. Next, 2 plus 3 gives me 5. So that works as well. In conclusion, the numbers 2 and 3 do multiply to give us 6, and they also add up to give us 5. If you remember, this method is called decomposition. We are now going to decompose this center term, positive 5x, into smaller pieces. So I'm going to decompose it into positive 2x and positive 3x. You'll notice that I got this positive 2 from over here and this positive 3 from over here. Everything else is going to stay the same. So the y is going to stay the same, the equal sign is going to stay the same, the 6x to the power of 2 is going to stay the same, and this positive 1 at the end is going to stay the same. You'll notice that we've decomposed or broken down this center term into positive 2x and positive 3x. At this point, we're going to take these 4 terms and separate them into 2 groups. And I'm going to separate them like so. I only want you to focus on these 2 terms right now. We are going to have to find the greatest common factor of the coefficients. This has a coefficient of 6, and this has a coefficient of positive 2. The greatest common factor of 6 and 2, in other words, the largest number that can divide evenly into 6 and 2, happens to be 2. Next, if you want to find the common variable with the lowest exponent, both these terms contain the variable of x, so I'm going to write that down. Next, the lowest exponent that we have here actually is a hidden 1. I'm going to write an exponent of 1 right over here. We are now going to take 2 and x to the power of 1 and combine them down here. So that becomes 2x to the power of 1. I'm going to take that 2x to the power of 1 and place it over here. In brackets, I'm going to rewrite what I had before, 6x to the power of 2 plus 2x. We now want to divide everything in the brackets by 2x to the power of 1. I'm also going to write in the hidden exponent of 1 over there. Since we are dividing terms, that means we're going to have to use the quotient rule. Before we do that, I'm just going to write out 2x to the power of 1, and I'm going to keep the brackets. So first, we want to take a look at the coefficients. So coefficients get divided. 6 divided by 2 gives us 3. Next, we need to take a look at the bases. Bases stay the same, so that base of x is going to stay the same. And last, we want to take a look at the exponents. Exponents get subtracted. So 2 subtract 1 gives us 1. We're going to repeat the same process. So take a look at the coefficients. Coefficients get divided. So positive 2 divided by 2 gives us positive 1. I'm going to write in the positive sign. Next, let's take a look at the bases. Bases stay the same. So that variable of x is going to stay the same. And last, you want to take a look at the exponents. So the exponents get subtracted. 1 subtract 1 is 0. Before moving on, let's clean this up. I don't need this exponent of 1 here. I don't need this exponent of 1 over here as well. And anything to the power of 0 kind of disappears. So I'm going to remove that. Let's repeat the same process for these two terms. First, we want to find the greatest common factor of the coefficients. This has a coefficient of positive 3, and this has a coefficient of positive 1. The greatest common factor, in other words, the largest number that can divide evenly into positive 3 and positive 1, happens to be just 1. Next, we want to take a look at if there is a common variable with the lowest exponent. I can see that this term has a variable of x, while this term does not have any variable. So that means there is no common variable. Okay? Now, down here, we're going to take 1 and combine it with nothing, and that gives us just 1. I'm going to take that positive 1 and place it over here. I am going to add a positive sign in front of it. In brackets, I'm going to add what I have above, which is 3x plus 1. Now, I'm going to divide everything inside my brackets by that positive 1. Since I have a term dividing another term, that means I'm going to have to use the quotient rule. So let's begin by rewriting that positive 1, and I'm going to leave the brackets. So when using the quotient rule, we got to start with the coefficients. The coefficient here is 3 and 1. We need to divide these numbers. 3 divided by 1 gives us 3. Next, we want to take a look at the bases. Well, there's a base of x here, and there is no base down there. But bases stay the same, so that's just going to remain x. And last but not least, we're going to take a look at the coefficients here. So positive 1 divided by positive 1. And that is going to give you positive 1. I now want you to think of everything highlighted in yellow belonging to one group and everything highlighted in orange belonging to another group. Ask yourself the question, what does this group have in common with this group? Well, you'll notice that the 3x plus 1 in brackets is common to both these groups. The y is going to stay the same, and the equal sign is going to stay the same. The 3x plus 1 in brackets is going to go over here. So I'm going to rewrite it as 3x plus 1. Now, you'll notice that there's a leftover 2x over here and a leftover plus 1. Well, those two terms are going to go together in brackets. In conclusion, we've just converted standard form to factored form through decomposition.